Okay, so this is section 5.4. This is all about e to the x. E to the x, of course, is the inverse of natural log of x, right? They are inverse functions. So if the natural log of x equals y, if y is ln x, that means e to the y equals x. So e to the y equals x, right? They are, and if you were to swap the x and y, you get y equals e to the x, right? They are inverse functions, Okay, so because they are inverse functions, properties of inverses apply, which means if I took e to the natural log of x, this would have to equal what?
Y.
1.
1 over y. Y to the fifth.
The e to the y.
Something to the y.
I don't like
X.
ln to the
E to the natural log of x has to equal x. And the natural log of e to the x has to equal
E.
x.
Duh.
Okay? Because they are inverses. Remember, f of g of x equals x and g of f of x equals x if they are inverse functions, right? Okay. All right, so properties of inverses. Tell me for, let's just go ahead and graph. If we were to graph y equals natural log x, which you're all somewhat familiar with that graph, right? Vertical asymptote at 0. Always increasing, always concave down. Increase has a very slow rate of growth. If we were to graph e to the x, it's kind of the opposite. It has a horizontal asymptote at 0 and goes up like that. It's also always increasing. It has an extremely high rate of growth. It grows really fast. And if you look carefully, this is y equals e to the x. The functions then have this lovely symmetry over what line?
Y equals x.
Y equals x. Because they are inverse functions, right? For y equals ln x, what's the domain of this function?
Is it x?
0 to negative or to positive infinity.
0 to infinity. And what's the range?
Negative infinity to positive infinity.
All real numbers, good. For y equals e to the x,
It's what?
what's the domain?
Negative
All real.
infinity.
All real numbers, good. And what's the range?
0 to infinity.
0 to infinity. And if you look at the graphs, you'll see that, right? The y values never go below 0. This has really important consequences when it comes to your calculus that you're going to be performing on E-related functions, because since the y value can never go below 0, think about when you have to make a sine line, e to any power in the whole world has to always be what? Positive. It will never equal 0, it will never be negative. It doesn't matter if it's e to the negative 1/millionth, that just means 1 over e to the millionth, right? So it's really small, but it's not 0 and it's not negative, right? E to any power is always positive, okay? And we're going to use that knowledge later on when we make sine lines and stuff. Okay, one more quick little thing regarding these graphs. Say I asked you what the limit as x approaches negative infinity of e to the x is. What is the limit as x approaches negative infinity of e to the x?
0.
It's 0, very good. What is the limit as x approaches positive infinity of e to the x? It's infinity. Remember, that's the y value that the function's approaching, right, on the right-hand side.
Gotcha.
Does that make sense?
Mm-hmm.
Okay. Good. All right, next we're going to do a little bit more pre-calc stuff. we're gonna solve some equations. We're gonna start with how about an exponential equation first?
Yay.
Exponential meaning the variable is in the exponent. There are a couple ways that you could do this. One way would be you could write this in log form, or the other way would be to take the natural log of both sides. You could do either way. It doesn't matter. Potato, potato. So, everyone take a moment and see if you can figure out how to solve that equation. You can talk to each other. It's okay.
Alright guys,
Will be an actual number or would be the same as an actual number?
should we square
What do you think?
Would not.
Let's write it in.
Well, the base of our exponential is e, so what log do you think would be a smart way to use? A log base e, right, or a natural log?
What's log to log, natural log of e is 1, right?
Yeah.
I got Alan said
Yeah, 1, okay. So just Alan 7 minus 1, right?
X minus 1.
Yeah, I was just checking it out. It was so turned. I learned that I can do handstand push-ups, you know?
Dragon.
Dragon push-ups, yeah. On like a circular
No, how are we missing in your picture?
circular device.
Grab it and think.
It's like a giant, like a barrel or stuff. Yes,
Okay.
I don't know, I can do dragon.
How many did you do?
Charlie, what are you missing?
I like 1.
Yeah, those are almost impossible. They're really tough.
Well, yeah, no, yeah, I'm sure he is.
Yeah, somebody's like holding me so like hollow.
Well, they're probably like holding you up, so it's like holding.
No, I was, they were putting their hands like right there.
Okay,
Not holding you.
so
Yeah, they were like this, they were like, so I could like lean against them.
I'm going to take the natural log of both sides. So we get ln 7 equals ln of e to the x plus 1.
Ooh, x plus 1 to the front.
Okay, yeah. You could, there's a couple ways to think of this. If you look back at the property of ln of e to the x is x, ln of e to the stuff is the stuff,
Oh.
right? So you could just say, hey, ln of e to the x plus 1 is x plus 1, right? But if you're not sure why, just remember that you can take that x plus 1, put it in front, and then what is natural log of e?
1.
It's 1. It's a fly. Okay. So anyway, so then you just subtract 1. So x is ln 7 minus 1. Does that mean that's ln 6? No, totally separate from the argument of the log, right? It's the natural log of 7 and then minus 1. All right, good. Let's solve a logarithmic equation. So suppose we have ln of the quantity 2x minus 3 equals 5. So in this problem, when you have a logarithmic equation to solve, you either write it in exponential form or you exponentiate both sides. When you exponentiate both sides, what that really means is you make each side an exponent. And of course you would want the base to be e, right? So you can either exponentiate both sides or you can write in exponential form. Personally for this one, I think writing in exponential form is much faster and easier. But it only, well, technically it only saves you one step. All right, take a moment and see if you can figure it out.
I'll take a minute. You go to the
Okay. All right. So, how do you want me to do this? Do you want me to exponentiate, or do you want me to write in exponential form? That's what I like. Okay. Guys, shh, you want me to do both?
Yeah.
Oh, okay. So if we exponentiate both sides, meaning we make each side a power of e, alright, then you have to recognize your properties. E to the natural log of 2x minus 3 equals 2x minus 3. Right? And then, remember, e to the fifth is just a number. So we add 3, 2x equals e to the fifth plus 3, and then x is e to the fifth plus 3 all over 2. If you write in exponential form, think of there as being like a little invisible e here. Remember, base to this power equals this. Base, this base, that invisible e, to this power equals this. And all it does is it just takes you right to here, right? E to the fifth equals 2x minus 3.
So these problems get more difficult.
Yeah.
So either way is fine. Are there questions? Does this make you, is this okay? Now, one of the things I want you to get in the habit of doing, I want you to get in the habit of solving these equations, not assuming you know there is or is not an answer. For example, I saw last week when we were doing logs, a lot of people got an equation like ln x equals -2 and told me there was no solution. But if you write it out in exponential form, you get x equals e to the -2nd, which is just 1 over e squared, and there's a perfectly valid answer, right? So make sure, don't assume that you know there's no answer just because you see a negative, that you think it's not. You can't have a negative here, but you can have a negative here, okay? So just be careful. Go ahead and always try to solve those equations to make sure that you know, don't miss out on any important answers. Alrighty. Okay, is that all the backgroundy stuff we need? Nope, we got a quick review exponents. Okay, so remember, since we're dealing a lot with exponents here, remember e squared times e cubed. What do we do when we're multiplying same base with exponents? Add them. So e squared times e cubed is e to the fifth, right? See, so e squared times e to the x is e to the
2x.
Ooh. What is it?
2 plus
2 plus x. Be careful, don't fall in the trap. Right? E squared times e to the x is e to the 2 plus x. So now if I had e squared raised to the x, that would be e to the 2x. Right? Or if I had e to the x times e to the x, that would be
2x.
e to the 2x. Okay? Be careful with your exponents. Hey, quick question dealing with e's and exponents. If y equals e squared, what's y prime?
No,
Zero.
0.
0.
Haha. Gotcha. Gotcha. Right? What's e?
Constant.
E is a constant, right? If there's no x's here, if there's no variables, because e is not a variable, it's a constant, right?
Oh.
We never solve for e. We already know what e is,
We do
right?
2.18.
2.718. If you're graphing with e, e is always around 3, right? If you ever have to approximate with e, use 3.
What if I do exactly E?
That would be impressive.
Like to the billionth decimal?
That would be very
How impressed
impressive.
would you do? If I just wrote on my test E to like the millionth decimal, would I get 100?
No.
Why
Doesn't
not?
it terminate?
No, it never ends. Like, if I
No, e is irrational. It never terminates.
But if I memorized all of that.
Yes?
Would the derivative of e to the x also be 0?
No. No,
They actually-
because there's a variable in there, right?
What would
The
we
reason that the derivative of e squared is 0 is because y equals e squared is a horizontal line, right? So its slope is always 0.
Wait, then-
But e to the x is not a horizontal
So
line,
what's
right?
the derivative of e
slope-
to the x?
Funny you should ask, right? Let's play name that derivative.
Little does she know, I have no cards that she gives me before class to ask all these questions.
Alright, so, just very quickly,
Don't talk back to me, stuff.
alright.
Wait till you're tired.
Alright, go, there you go.
Okay. So I'm using my somewhat old, but still very much loved TI-89 graphing calculator. And in y equals, I have put the function e to the x. Let me zoom in a little bit here.
You should focus, there we go.
There we go. Okay, so in y equals I have the function e to the x, in y1. And then in y2, I have the derivative of e to the x. Alright? Let's take a look at our table and see if we can figure out what the derivative of e to the x is. So y1 has the values of e to the x for, a bunch of values of x, right? There's the actual e, right? E to the first, 2.718 rounded. Okay, so y1 we have e to the x. In y2 we have the derivative of e to the x. So what do you think the derivative of e to the x is? It's e to the x. E to the x is its own derivative, right? It makes it very nice, except
What?
for the fact that you're not going to get 50 problems that say what's the derivative of e to the x, right?
Are you
So,
trying to trick us?
no, we're not.
So it'd be the exact same graph.
Yeah, do you want me to show you the graph?
Yeah.
I mean, I already put it away, but I can pull it back out here. Show you the graph.
Show me the money.
Okay.
Get these lips all chapped up.
Alright, so graph. There's e to the x and its derivative graph.
That's only one graph. Did you just lie to me?
I did. Here. If you want, I'll blank it out. Here. Okay, so now all I have graphed is the derivative. Going back to the graph. There it is.
And so the derivative of y equals the other one.
Y
x,
equals
its derivative would not be the same.
No. Derivative of ln x is, derivative of ln u is u prime over u.
Then would the derivative of an inverse be the same as the
The derivative of an inverse, if you want the derivative, how do I say this? The derivative of an inverse, or f inverse prime of x, is 1 over f prime of f inverse of x. Hence the lesson that we did last week, Wednesday, right? When we studied derivatives of inverses.
Sassy.
Yes. So, no, I'm not being sassy. I'm just telling you. So, yeah, derivative of an inverse is not, you don't just do the same thing. It's a little different.
That'd be so cool if it was.
Wouldn't it though? I know. Okay. So let's do a few examples just so you get, first I have to write the rule. So, if y equals e to the u, so u represents the argument or the exponent on our e function, then y prime
I don't know what you're laughing about. That went in.
is e to the u times u prime.
And you just stand.
Or
for
you could
stuff.
say e to the u du. But it's the function, the e to the u stays the same, but then you have to multiply by the derivative of the exponent.
Oh, is that why? Because x's derivative is 1, so
Yes.
it's just the same
So
thing.
it's just 1 times e. Yes,
Is that u prime or u inverse?
that is u prime. Yes. You could write it, if you want to write it as e to the u du to tell yourself it's the derivative of u, that's fine too. Okay. So anyway, so for example, suppose y equals e to the 8x cubed minus 3x squared plus 5.
Take the derivative of that.
Everyone take a moment and find y prime.
Yes, Mustafa. That's how we do it in this group, because we're overachievers.
What's e? Original equation.
Do your kids drink Capri Suns?
Sometimes, we call them Capri Suns.
Capri Suns, first of all. And second of all, have you ever seen the new sports Capri Suns?
I am not.
They come with a resealable cap, so you can like run with them.
It's like
So-
the old Gatorade bottles.
Because we always just do the,
Yeah, but there's also a new one where it's like the same type of pouch.
I don't
You can like reseal it with like a thing, and then you can
Really?
run. But it's like I always drink those in one little squeeze. I
yeah,
just,
they're so small.
yeah, so like I don't understand the point of that. Like I never just take a sip of Capri Sun, but
My 5-year-old can suck down a Capri Sun
Yeah,
in
it does.
probably 15
Always
seconds.
trying to tell us we're all
Yeah.
going.
so I don't see the purpose of the sports one, but it's pretty cool.
Okay, so anyway,
What is it?
so here's what you get. And by the way, if you want to put the derivative
All I know is
first
Capri Sun.
times e to whatever, or put the e first, it does not matter in any way, shape, or form. Okay, whatever you prefer. So, I might mix it up just for fun, right? So, I'm going to put the e first on this one. So, remember, e to this power, the exponent never ever changes, right? And then we multiply by the derivative of the power. It's basically just chain rule, right?
So gross.
So you always multiply by the derivative of the input, so 24x squared minus 6x.
See the carrots and green beans,
Does that make sense?
celery.
Yeah.
Yeah? Okay, let's do one that I think is easy, but for some reason first period did not like this.
That's so easy.
Everyone have their answer?
It's negative.
Well, this time I'm going to put the derivative first. Okay, so we get negative 1 times e to the negative x, or negative e to the negative x. Does that make sense? Yes.
Write a negative 1 over e to the x.
Oh, you could do that, absolutely. Absolutely. Yeah, guys, did you all hear that? He said, could we rewrite this as negative 1 over e to the x? Oh, sure, absolutely. They're equivalent. All right, learning the derivative of e to the negative x as negative e to the negative x will make your life a little bit easier. Easier, get it?
I'm good at Oh.
Okay. All right.
Where can you buy a ruler that is 3 feet long?
The yard sale.
I wrote the joke, I know the answer. At a, you can say it.
I don't know it.
The answer's right there.
Oh, at a yard sale.
Get it?
Now I get it.
Ah, bro.
At a yard sale. Oh.
You make these up?
Walmart.
No.
Supplies.
I don't do yard sales. I do garage sales. Where you sell stuff from inside your garage.
Same thing.
Just in case it rains, I don't want all my furniture to get dirty.
Why would you be selling furniture?
Oh, but how else would you sell your furniture, Mustafa?
At an estate sale.
What'd you plan for that?
Bring your.
All right.
Well, I have a set weekend for my yard sale.
Here we
If
go.
it happens to rain, then
We
I
have
have
this
to reschedule my entire,
function.
like,
I'm not asking for the derivative, so just hold off for a second. G of t equals 1 plus the quantity 2 plus t times e to the negative t. Here are your directions. I want you to find all extrema and points of inflection.
Ew.
Now, in order to find the extrema, we're first going to have to find what?
The first derivative.
First derivative. Everyone take a moment and do that.
So GT prime, is that not G prime?
Stop, Mustafa, stop.
Exactly. Oh, use product. Would you?
Yes, you would.
By the way, 12 weeks are up. Grades are due by all teachers tomorrow morning at 9 a.m. So you will be getting your progress report sometime this week.
Except Mustafa, who doesn't have to test it.
I had after school today.
2.24.
That'll be good because you don't want that going in as a 0 on your report card.
Can you please put it in as a 0?
I mean, I don't show it to my
So
parents.
that would be
His dad would freak out, and then he'll come to school, and he'll like not have a phone and not have clothes. That's where a sign that says I failed AP Calc.
Come to school naked.
Like, I mean, why is it derivative? Why is it
Everyone got this derivative? Do you need another minute? Hey, what rule do you have to use for this derivative? And change, yes.
E raised to U times
Okay,
U
so
prime.
derivative one
The
is
derivative of
Good.
x.
F prime G plus F
What are you saying? You were
Is the
literally
final
no
in
F.
here like AP style questions, or is it just gonna be
The
like?
final in here is
optional.
a manufactured AP exam.
Alright, so
We can't use a real AP exam because obviously a real thing would have second semester material on it,
Yeah.
right? So we made up our own AP style AP
Is it gonna be
exam
curved?
Why don't you just take
that
an
we
AP
give,
exam?
and we grade it AP style,
Oh, okay.
So
yes.
that AP.
which is very much to your advantage.
Wait, why don't you just take an AP like exam? Take all the second semester questions, then just add in a bunch of like first semester questions from another AP exam.
Wait, will it come on
We have done
Saturday?
something of a similar nature to that, but we can't use public exams because then you guys could just find them and look them all up, right?
I can't memorize like 80 different things.
Yeah, there'd be
So
like
we
80
wouldn't know
different
what
tests.
tests
You'd be like trying to memorize like 80
Isn't it from
different
like
answer keys.
1984? I wasn't even live back then. There's
I mean,
point
like-
looking back in the.
Wait,
You
Miss
could
Price,
give me like the answer key. I could
Those
study
are-
like
those
for
are
10
equal.
questions. I could study for like 20 minutes. I still only remember like the first 2.
wait,
I would remember there's like a 5 in there somewhere. I just write a 5 and get like partial credit. That's about it.
Will we have to come in on Saturday?
No, you do not have to come in on a Saturday.
Thank you.
We should all have a party next.
You will
Friday.
take the free response portion before final exam day, and then on final exam day, you just take the multiple choice portion.
Why?
We should have a fiesta instead.
A fiesta,
Yeah, like we all bring in food.
Or a
maybe
slaughter.
after the AP exams, I
No,
would be open to that
before.
every day.
We should do it before just so we can like, or on Pi Day.
Alright, so anyway, derivative 1 is 0, derivative 2 plus t is 1, right? Times e to the negative t plus 2 plus t times, what's the derivative of e to the negative t? Negative e to the negative t. Whoa, I just asked you guys for that.
Alright.
So we combine like terms, so we have e,
Alright,
let's
that's
just
right.
distribute first. So minus 2 e to the negative t minus t e to the negative t. Write down. So you get negative e to the negative t minus t e to the negative t. Whenever I have to find critical numbers for an e kind of function, you're going to always want to factor that e out, right? So you end up with e to the negative t times negative 1 minus t. Or you could do negative e to the negative t times 1 plus t. Whatever you prefer. Doesn't matter to me.
Miss Price, I
Yes.
don't really understand the first part you did.
How we got the derivative?
Yeah.
Okay, well the derivative of 1 is 0, right? So that's just gone. So here we had to do what rule?
Product.
Product rule, right?
Why?
Because it's a variable expression times another variable expression. It's something with a variable times something with a variable,
Okay.
right? So f prime, so we did derivative of this, which is 1, times that, plus this times the derivative of that.
Okay.
Whenever you have anything with a variable times anything else with a variable, you have to do product rule. Alright? If you have number times something with a variable, then you don't.
Okay.
Right? But variables times variables, you're in product rule. Alright, so for this, let's set each term equal to 0. So we get e to the negative t equals 0. When is that true?
So we have taken natural logs.
Alright, E, I was just copying it down, so I just got to use it.
And 0.
It
What's the
never,
natural log of 0?
it never equals
1?
0. It never happens.
This is never true. E is never 0 because e to any power in the whole world is always what?
Positive.
Positive.
Or greater
It
than
is
0.
never 0, it's never negative.
You tried to trick us,
I am.
but you couldn't get me.
Okay, so for this one, we get t equals what? Be careful. Negative 1.
Your kids ever watched Peter Pan?
Sure. So we make a sine line for g prime. Hey, lucky for us, e to the negative t is always what?
Positive.
Positive. So if I pick a number like negative 10 and I plug it in, I get negative 1 plus 10, which is positive. If I pick a number like 0, I get negative 1 minus 0, which is negative. This function is increasing and then decreasing. We have a rel max at negative 1 comma something. Why?
Because it changes from
Because
positive. Oh, g prime t
G prime of t,
changes from positive to negative.
very nicely put, changes
Thank you.
from positive to negative. Where do I get the y value for the max?
Plug it back in the original equation.
Plug negative 1 into the original equation. Everyone take a moment and do that.
Okay.
Just do it. You can do it.
Wait, so if it's negative t to the negative, like what? Do you like cancel out the negatives?
Correct.
Alright, so it's just e to the 1. So then that's like e. No, yeah, that's e. E to the 1 is e. So e times, what's, oh, is it just e? It's 1 plus e. So like, you know in Captain Hook, or Peter Pan, you know how there's like that crocodile that like swallows.
Do you guys all understand how he got 1 plus e?
Yeah.
Alright, good.
You know how there's that crocodile that swallows that clock?
But one moment, please. Alright, we're going to find g double prime. When you find g double prime, use this guy for your g prime. Alright, and take the derivative of that. Alright, so we're going to find g double prime, given that g prime is e to the negative t times negative 1 minus t. So I want you to find g double prime.
Oh my gosh, my head's like a math
What's the derivative of e to the negative t?
What is the derivative of the negative t?
I was asking you this, Bryce.
And I'm asking right back.
That's not how I questions work.
That's not why I pay taxes.
I don't actually pay taxes, so.
That's bad for you because you're such a not hardworking citizen.
Anyway.
Me, JP.
What I was saying is, you know there's that crocodile that swallowed that clock? I was thinking that you should put a crocodile around your clock to like symbolize that. What do you
I
think?
will take that under consideration.
If I make a crocodile poster and then cut a hole out for your clock, will you put it up
You know
there?
my French teacher doesn't have a clock in the room. Like, who does that?
I would consider it.
Yeah.
Could the crocodile be in some way related to math?
What if it's like
I'll make
a
its
math
eyes
project?
like
Angry like when you
circles.
take out your phone.
And pretend there's like a graph in there.
So I lose your class. Yeah,
And I'll make it's like
Okay,
4
so
out
we
of
got
5.
to use what rule for this one? Product rule. So the derivative of e to the negative t is negative e to the negative t. I'm hoping you've learned that by now. Times negative 1 minus t plus e to the negative t times, what's the derivative of negative 1 minus t? Negative 1. There are like a million negatives in this problem. So when you distribute, please be very careful with your signs. So, everyone take a second, distribute all the negatives, combine like terms.
E to the negative 2.
I may just be slow or something, but I'm still not getting like negative e to negative t.
Just 1 plus 2.
For your derivative of e to the negative t?
Yes.
Oh, okay, well, let's just do it as its own little problem. Okay, so suppose y is e to the negative t. So y prime would be, well, it's e to the u du. What's the derivative of negative t? Negative 1, right? So you just keep the e the same,
Okay.
times the derivative of the exponent, and then you just put the negative 1 in front.
Okay.
Alright, I think I got this. This is pretty.
Yeah, you think so?
Is it e to the negative 1 times t?
T over E.
The exponent
Yeah.
should never change.
It's t to the negative te to the negative 1. That's what I had.
Not 1.
That's what I meant. That's what I said.
Close enough.
T e to the negative t?
Yeah, that's what I said.
Okay, good.
It's because my t's look like 1s in my
Be
handwriting.
careful with those. That's why I do t's with like a kind of a curled bottom, so they don't get confused with like plus signs or anything.
We started as like a half.
No, that's fine.
What if we brought
Okay.
the
So now we need the zeros of this, so we either get t equals 0, or e to the negative t equals 0. When does e to the negative t equal 0?
Never.
Never! So our only critical number is 0. If I plug in negative 10, this function as a whole is what? Negative, right? Because the t would be negative and e to any power is always positive, right? If I plug in positive 10,
positive?
it's positive. So we are concave down, concave up, and we have a point of inflection at 0 comma something y.
Because f double prime.
Close. Because g double prime changes sign. Where do I get the y value?
Plug it back in.
Original function. Everyone do that.
Alright, so it's gonna be what's 2 plus 1? It's gonna be 3. Be 1, it's gonna be 1. You sure? No, because e to the negative 0, what is that gonna be? That's gonna be like, alright, if e to the 0, that's gonna be 1. So 1 times 2, that's 2. So then 2 plus 1, that's 3. So I was right the first time. Don't doubt me.
Did you guys all get 3? The questions on how Nelson got 3?
I'm questioning what he was saying.
Okay, here we go. If we plug in a 0 to this function, right? So we're doing g of 0. We get 1 plus 2 plus 0 e to the 0. What is e to the 0? It's 1, right? So you end up with 1 plus 2, which is 3. Okay? Alright, good. That's that problem. Hey, before we move on and do another relative extreme of point of inflection problem, which we are going to do in a moment, hey, let's just have fun and do one more e derivative. Let's just see if you get them.
Nah, bro.
Suppose f of x equals e to the square root of 3x squared plus 5. I want you to find f prime.
This is easy peasy lemon squeezy. My
Good.
grandma could do this in her sleep.
Oh, that's awesome.
She wasn't dead. This is literally like taking all of this stuff.
Oh, do the 1/2 sack shop.
Dude, that was like 5 minutes. This is like chain rule, product, or chain rule, and
And
yeah,
that's
all
it.
of It's right. It's just chain rule.
Just change.
But it seems like a lot more. 'Cause
It
there's like,
seems like more. Once you get the derivative, I'd like you to simplify it, please.
nah. No. Oh wait, no. It's really simple. It's just 2x, and then you're done, right?
I'm not sure.
I think it's right.
Okay.
Do you feed your kids vegetables?
From time to time.
Like, what's their favorite vegetable?
The only vegetable that my younger son will eat is corn.
Corn.
Yes.
Kettle
Yes.
corn.
He used to eat peas. He said that when he turns 6, he will start eating peas again.
6.
Yes.
How old is he?
He's 5
Once he turned 6.
in a few weeks.
You know
That's
what
one
you
of his
should
promises.
you should feed him. You should feed him like zucchini, but bake it.
Do
in
you
the
know,
oven.
I used to fry zucchini without breading, but just like slice it up and cook
Yeah.
it in like a fry pan for my older son, and he would eat it like it was candy.
Samesies.
I like
Oh,
green
yeah.
zucchini.
Yeah,
Or you can do like onions that way.
yeah.
You can do them both. What my mom does is she bakes zucchini and like little bits of bacon and then like a bunch of cheese on top in the oven, and then she like has like this like, you know that like whipped cream that you buy at, like the grocery market that's unwhipped whipped cream.
Yes, whipping
You,
cream.
you pour that into it, and then it's just like you like then stir it after you bake it, and it's really good. I recommend that.
Sounds like a good cook.
Sounds like, it
You know
does
why my
sound
mom
very
sounds
good,
like a
sounds a
good
little
cook?
heavy,
Oh, she's French.
Defeats the point of eating vegetables.
yeah.
It doesn't. It's not that unhealthy. I'm gonna be honest. with you.
I feel like that is.
Why is it unhealthy?
Okay, talk to me about the first step. Do I need to walk you through?
Yes.
Okay, so e to
And then
the
there's like
exponent
coding.
stays the same, right? Times the derivative of the exponent. Guys, hush. This is 3x squared plus 5 to the 1/2 power, right?
Yeah.
So the derivative is 1/2 times 3x squared plus 5 to the negative 1/2 times the derivative of 3x squared plus 5, which is 6x. Is that okay?
Yeah.
Morgan, you look upset. Tell me what's
I
up.
don't understand anything.
Okay, do you understand that the e stays the same? Good. So if I just asked you, hey, suppose y is this, could you tell me y prime?
General? You mean
Yeah.
1/2 times, oh, okay. 3x squared plus 5 to the negative 1/2, oh, thanks, Nutter. Okay, I get it.
Do you get it? Okay.
Wait, wouldn't the 1/2? Couldn't you simplify it?
We are about to simplify. We haven't
Three.
simplified yet. But we gotta make
3x.
sure people understand this step before we move on, right?
Gooch.
Okay. Does this,
Have
any
you
other
written
questions?
your name on this? What if somebody steals it?
Anyway, so let's clean up. So this stays on top, right?
If you don't write your name on this, Ms. Price, I might be tempted to steal it.
Okay. There's a 2 on the bottom, but there's a 6 over here. I'm going to cancel those and make that a 3. This 3x is also on top. I'm going to put them in front. And then this goes to the bottom.
It's because she was third order pass, which according to her isn't that good of a student.
Who's